Now, and we come to the second part of chapter 6. And now, just now, and in the last week, we talked about trusses. Trusses, what is this one? And now we talk about frames and machines. Frames and machines. Now, in let's have a revision of what are trusses. Trusses are in trusses we have two force bodies. We have only two force bodies. All in trusses, all of them are two force bodies. This one is two force body. This one is a two force body, and this one is two force body. But now we are going to have frames and machines. In frames and machines, now we have multiple force members. We have multiple force members. Maybe three force or more. And we have two words. We have frames and machines. Frames are and machines are these two words. In there is a difference between frames and machines. Frames are and the frames are rigid bodies and machines are not rigid bodies. But this is for in this textbook. But in the coming hour in my discussion, the biggest difference is two force body and multiple force members. Okay, maybe three force body or maybe more. Now there is a difference between the two in the questions. Now for trusses, what do we need to? In trusses, we determine what? What do we determine in trusses? We determine forces in members. We either have T or we either have C. What's T here? Tension, cooling. And what's C? Compression. Okay, very good. Now, for frames and machines, when we have multiple force members, and when we have multiple force members, what we determine are forces. We only determine forces between members here. Okay, we only determine forces between members. For forces in members, of course, it has forces in each member. We have forces. It is in the chapter 7 of the book. And we are not talking. We will not do chapter 7 in this course. And you will do internal forces in the next year's mechanics of materials. Is it okay? So in trusses, we determine either each member is in tension or in compression, T or C. But in frames and machines, that we determine forces between members. I will show you. And for forces in members, that you will do it next year. It's okay. Now, and of course, and for this kind of problems, we always have we will have an SOP. And the SOP in this kind of problem is to first remove the supports and remove the supports. Remove the supports, and then we analyze rigid bodies only. We analyze rigid bodies only. In free body diagrams, we only have rigid bodies. It's okay. Now let me show you an example. And let's look at the example below. Let's look at the example below. We have two. It is you can say it's a frame or machine. I don't see it. Now we have two. In this structure, we have AC and CB, right? We have AC and we have CB. Are AC and CB two force bodies or not? Are they two force bodies? Let's look at the structure and let's see if AC and CB are two force bodies. What do you mean by two force bodies? Let's have a look at chapter 4. Let's have a look at chapter 4. And I will come back to this page. Two force bodies are bodies with external forces acting on 2 points of the body. 2 points of the body, okay? External forces acting on 2 points of the body. Now we come back to page page 49, right? So are these two force bodies, AC and CP. Let's talk about AC first. So because there is a joint, so we have two forces. It's a pin joint, so we have two forces here, right? And now at point C, we have it is also a pin joint, and we have force because it cannot move to the left or to the right or to up to down, and so we have two forces here. And then we have points. We have P acting somewhere in the middle. So external forces act on point A, point C, and the point in the middle. Let's say point D here. It's okay. So this AC is a free force body. It is not a two force body, it is a free force body. CB is also a free force body. So I will say okay. It's okay. Now, and we go to let's say we want to draw the free body diagram for this structure. Let's say we want to draw the free body diagram for this. Now, At point A, it is a pinch joint, so we have forces to the right and force to the upwards. And for point B, we have force to the right and force upwards. And so if we have, I think let's do it like this. So for this structure, and the natural way to draw the free body diagram is this one, right? Because we have pin joint on the left and pin joint on the right. So for the left hand side pin joint, we have AX and AY, and for pin joint to the right, and we have BX and BY. Now looks natural, right? Now the next thing, how many unknowns do we have in this graph? How many unknowns do we have here? Or what are the unknowns here? Suppose we know P and Q. What are the unknowns in this problem? We have AX, AY, BX, and BY. All of them are unknowns, right? So we have 4 unknowns. How many equations do we have? 3. So it seems, of course, this is not okay, because we have 4 unknowns and we have only 3 equations, right? So next, you may say, so if when we have this problem, we may say, oh, let's look at this system. Let's draw it like this. But this sound still looks strange, because if we put these 2 forces here and this one can slide, what happens? It will go like this, right? So this is not okay either. So what's the problem here? Now, the problem is that we need to draw free body diagrams for rigid body. So is this a rigid body? No, it is not a rigid body, because this can rotate. Okay. So we need to draw free body diagrams for rigid bodies only. Analyze rigid bodies only. We count the number of unknowns and equations for rigid bodies only. If a machine is not a rigid body, if it is not a rigid body like this, break it down into rigid bodies. Break it down into rigid bodies. Break it down. Break it down into rigid bodies, like the one in the middle. It's okay. Break it down into rigid bodies. So in this system, we have, and then we draw free body diagrams for each rigid body. So in this equation, so in this so because we have two rigid bodies AD, AC, and CB, so we need to draw two free body diagrams. How many what are the unknowns in this system? AX, AY, BX, CY. What else? We have here CX and CY. Okay, and CX, CY. That means we have 6 of them. Now, after writing it down, how many equations do we have? How many equations do we have? On the left, because we can we can use equilibrium equations to each free body diagram. So we have 3 equations to the left and 3 equations to the right. So we have 3 times 2 equal to 6 equations. Because on the left for AC we can have 3 equations and we have 3 equations to the right. So we have 6. Okay. Now for this, the free body diagram in the middle also show us something else. That's for point C. Point C, we have AC and we have CB, and they join, they meet each other at point C. So to determine the forces to draw onto the free body diagram, we use this way. We first consider one of them, and we put CX to the right and CY to upwards, and then by action and reaction, we have if this is to the right, then this means on the other side we have to the left. Okay, action and reaction. And this one is to upwards, and this one then it goes downwards. Okay, action and reaction. So that's all for, and that is what we are going to do on the next page. So we go to, after you finish writing this, and we go to page 50 to see one example. Now, and so sample problem 6.5. And to work on this system, the SOP, the first step is always do the free body diagram of the whole analyze to get the support forces, and as in chapter 4. So we have a free body diagram like this. And we have points A, B, C, D, E, and F. And for point D, we have 240 Newton to the downward. And for point E, we have because we have a pin joint here, and so we have EX and EY. And F is roller joint. We have one force going up. Like this. And then you work on the you get the, because the frame itself is a rigid body, that you can draw the free body diagram of the whole frame and get the free forces. This is a rigid body, okay, because it is it cannot rotate by itself, so we can determine these free forces. For the next thing, we want to determine the forces acting on members. Or I would say forces between members. Forces between members. Now, and I will take two examples. One of them is A, B, E, and other is B, C, D. So let's work on the A, B, E. A, B, and E. And this is 2.7 meter and 2.7 meter. In this problem, at point A, we have ACD connecting. We have ACD connecting at point A, right? And we have BCD connecting at point B. Now, you may want to guess the forces, the direction of forces, but in working with frames, we do not need to do this. We simply draw forces in X and Y direction, and by doing calculations, you will know the direction of the force. And for point B, we do the same thing. And for point E, of course we have determined forces at point E. So simply write EX equal to 0 and EY equal to 600 Newton. And this EX and this EY, AX and AY. after writing it down, think about it. How many unknowns do we have here? And how many equations do we have? How many equations do we have here? How many equilibrium equations do we have for these 2D rigid bodies? 3. So we have summation fx equal to 0, summation fy equal to 0, and let's say we use a point. Which point we use? Let's say mp equal to 0. And we will get the following equations. For fx equal to 0, because ex equal to 0, so because ex equal to 0, so we only have ax and bx. Ax plus bx equal to 0. And for fy equal to 0, it is ax plus ay plus by, ay plus by plus 600 Newton equal to 0. And for mb equal to 0, that because ey and ay goes through point B, so that's so for point moments above point B, because ey and ay goes through point B, so moment arm is equal to 0. So the only force with non-zero moment arm is ax. So it is minus 2.7 meter. Ax equal to 0. So we have equations 1, 2, and 3 here. We have, how many unknowns do we have here? 4. But we have only 3 equations, so we cannot determine everything here. Okay, we have only 3 equations, but we have 4 unknowns: ax, ay, bx, and by. So what do we know here? From equations 1 and 3, we know that ax equals to bx equal to 0, right? So what happens to this one? So we need to consider, so it means we need to consider the free body diagrams of other rigid bodies. We need to consider the free body diagrams of other rigid bodies to get ay and by. We need to we need our free body diagrams from of other rigid bodies. For example, we take BCD. B, C, and B, C, and D. Now, and the dimension is like this. The dimensions are like this. Now, what do we know any of the forces here, because we know we have 2,400 newtons acting on point D, and for joint C we don't know anything, so we draw, and of course the other member go this way, but we don't need to guess the direction of the force. We simply write Cx and Cy. Now, the last question is about point B. Of course, we don't know the forces on point B, but in this free body diagram, we have Bx and By here. So, by action and reaction, I suppose you know this word, right? And by action and reaction, we have, if we have Bx to the right on member ABE, that means we will have a reaction of to the left on member BCD. Using the same principle, if we have By going upwards on member ABE, it means we have a reaction going down on member BCD. It's okay because this is by Newton's third law. So if we have Bx to the right here and then we have Bx to the left here, and if we have this By going to the going upwards here, and we have By going downwards. So we have from here, from this rigid body, we can write another free equation. Which one I using MP. Now, for fx equal to 0, what do we have here? So here we have minus bx plus cx equal to 0. This is equation 4. Because we only have two forces going in the x direction, right? Now for Fy, we have Cy minus By minus 2,400, and this equation 5. So I should write down the. And for MB equal to 0, and for MB equal to 0, because these two are going through points B, we don't need to consider those. And because Cx goes through points B as well, so moment up equal to 0. So the only two forces we need to consider are these two. And what do we have? So we have 2.4 meter Cy minus 3.6 meter times 24,000 newton equal to 0. This is equation 6. So we have 6 equations and 6 unknowns. The only problem is how do you do it one by one. So I have I show you the order of doing things, but of course you know how. After I give you 6 equations, you know how to do it. Now, and we have Cx equal to 0, Cy equal to 3.6 kilonewton, Py is 1.2 kilonewton, and Ay is minus 1.8 kilonewton. And this is the answer. Now, and before I make the before I end the lecture today, I want to go to the next page after you have written this down. After you have written it down, I want to go to the next page before I end the lecture today. So we go to page 51. So we have in the past 2 weeks or 1 or 2 weeks, we have discussed chapters 4 and chapter 6. Chapter 4 will be examined this Friday, and chapter 6 will be at Christmas. So for chapter, but I want to say how I want to talk about. Sorry. I want to talk about how do we mark the forces. So in chapter 4 we talk about support, and we have pin support or roller support, these things, and you need to know which is which. Okay, you need to know which is which. You need to know what is a pin support, what is a roller support, and so on. Now, for marking those support forces, you need to include the direction. You need to include the direction. For example, like 100 Newton to the going up, or 200 Newton 30 degrees, like this. Okay, let's go to an example. Let's go back to the last page. For these support forces, we need to mark the direction. Okay, we need to mark the directions of support or support forces. It's okay. If we mark, this is the first thing. This is the first type or first kind. The second kind are in trusses. For trusses, we are determining the forces in members, so we need to mark either tension or compression. Newton, for example, 100 Newton T or 100 Newton C. T means tension, and C means compression. So I want to ask one question. So of course, in trusses, we calculate either a member is in tension or in compression. But in the beginning, so should we put everything in tension or should everything in compression? Tension, okay? So assume all members in compression. In tension, sorry. Assume all members in tension at the beginning in drawing free body diagrams. And for the last thing for frames, for forces at joints or between members, and we only need to say, for example, AX equal to 50 Newton or so on. And directions are not required in answers. There is a small difference between these three, but after doing your homework, you should be able to get this.